So there's a concept that I think about a lot at work called computational kindness. And the point is to recognize that computations take mental effort. For example, if you have to send emails, or if you have to think of options, or if you have to search for a pull request, the kind thing to do when working together is then to minimize the computation you're imposing on your colleagues, which also usually results in fewer computations on your end. Here are a few example scenarios between two coworkers. Let's start with the first one. So it's a tech lead who interacts with the engineer, and the tech lead wants some information from the engineer. Hey, when will your fix make it to prod? Engineer then say, I submitted yesterday, so it should be in the next release if it made the branch cut. At this point, the tech lead would be like, man, I just want a date. So I'm going to ask you, can you help me give me the exact release date? Finally, the engineer gives me the information that I needed. Um, so it's a bit frustrating that I have to send a second clarification message. Here's how it could have gone better. Hey, when will your fix make it to prod? Here's the PR. It's part of this release according to this release calendar, and it will make it to prod next Monday. Awesome. So what is the lesson here? So as the engineer, we can recognize that, okay, well, somebody needs to do the computation to find the exact release date. I might as well anticipate all the information that the tech lead needs, pre-compute it for them, and just give them the whole thing. It, um, there's also another loose metric that is displayed by this exchange. And this also is a something that I I think correlates with how much I like to work with someone. And that's the average number of messages I have to send until I get the information that I need. As a tech lead, it's even stronger than that. If I can get a clear response after just asking one question, I want to interface with this person more. And so I'm more likely to give them more responsibility over someone else who would give me multiple responses of poor quality, who have to waste my time asking for clarifications. Let's go to the next example. Now let's go through a similar scenario, but in reverse. Now you are the one who needs information from others. So say, hey, I encountered this exception. Can somebody please help debug me, debug with me? But then I'm asking for a full meeting, and then broadcast this like on the Slack channel. And usually what happens is when people look at this message, they'll be like, this is time consuming. I'll see if someone will jump in before I take a stab at this. And you probably don't get an answer until the next day. And then some kind-hearted engineer would say, okay, let's do it tomorrow. That's another delay. And then later you go on a 30-minute meeting and only to find out that it's another engineer's code that's at play. Um, then you have to set up another meeting. So this could take like at least 3 days already. So had we computed who should be on the hook and provided more context, we could have saved ourselves one meeting. Here's how it could have gone better. Hey, I got a null pointer exception. Here's the code, here's the stack trace. And when I look at the Git history, it looks like at this person is the one who made a recent big change. Can you help explain to me why? Then EdgeB would be like, oh shoot, okay, fine. This is like my change, and I know the stack trace because I've encountered it before. Um, so what's the lesson here? If possible, we should compute who the decision owner is and tag them. You'll save your entire team from having to decide who should I answer this, am I relevant? And you'll get your response faster. Another lesson is also to provide enough context and inputs to the computation. In this case, the computation is to debug. The inputs would be the stack trace. Yeah. So people can just answer in line on your chat app in after a few minutes of reading rather than having to go through expensive meetings with you. Let's go through one final scenario. In this case, you want to make small decisions. Um, let's say you want to align your team on figuring out how many rows to display in a single page. So you ask, what should we use for the page size? This is what you're leading with. Then the tech lead would jump in and say, okay, well, I don't have enough information. Can you give me some percentile data on how many rows a normal user usually sees? Then you do some computation. After a few hours later, you say, here it is. Here's the table to show the percentile data. And the tech lead will respond maybe an hour later and say, okay, fine, let's go with 50 rows because that covers 95% of our customers. Um, we could have done better. Instead of just posing a question to everyone, if we care about the decision, let's just do some pre-computation on our end. We could anticipate that um, we need the personal data. So first we pre-compute it. We start with a recommendation. I recommend 50 rows and I give a rationale and I attach some data. I also would give an alternate option. Another option is 100 rows if we want 99 percentile. Then we tag the decision owner, right? Instead of posing it to everyone. What do you think? Um, best case scenario, if you provided a good recommendation, the tech lead just says 50 rows a GTM. Done. You don't have to go back and forth. You don't have to set up meetings. Or if you have to set up meetings, at least you come with some options in mind. Or somebody would point out that, hey, you should also provide this other data. The lesson here would then be to help align decisions, it's helpful to pre-compute the options first and make a recommendation. Then in the best cases, somebody can just say, yep, you're good to go. Okay, that's all the examples that I have. So going forward, consider if you can be more computationally kind in your work interactions. Your colleagues would like to work with you better, and you can also get collaboration like work done quicker because you have fewer back and forths. So something to think about is, what can I pre-compute to be computationally kind? Thanks for listening.